And so what have you got there then?
So this is our own silicon. So this is a development board with our own SoC, so an IC that we developed in-house in PQShield, entirely by our own engineering team. So it's been over 2 years in development. We looked at all of the IPs in the PQ platform family. We wanted to put them into an ASIC technology and show how we could demonstrate them, demonstrate our capability as an engineering team, but also look at how these IPs perform in their real ASIC technology.
And so, was that the driver for doing it? Just first time right kind of proof?
I think that's part of it, proving we can do this, but also, up until now, how do we prove the technology we've built is via simulation or using FPGA technologies, which you can program things. But by building our own ASIC, we can demonstrate and test the IP in the way that a customer will use it, right? We can go and evaluate it in real detail, start to look at not only the compliance against the standards, but also things like security testing.
And so what have we actually put on the chip?
Everything we have under the PQ platform family is within the test chip. So that's our kind of flagship, coprocessor, the PQ Lattice, PQ CoPro, and also the PQ subsystem. So all of them are included within there, along with some research IPs as well. So the PQ platform family are focused on platform security for SoC, semiconductor vendors, these type of things, as you know. And they were built with security in mind, implementation security. So a big part of that's the side channel protection that we built into these IPs. And going forward, that's is one of the biggest benefits we have in having this availability of this test chip is we can do that in real detail. As I mentioned before, right, if a customer implements our IP, it's deeply embedded within their platform. We can't always get access to it, even if they gave us the silicon. But with our own test chip, we can we've got full control, full access. Allows us to really push the envelope in terms of the testing level we're going to do, and then look at how we can improve things going forward.
So some of the questions I've had when talking to customers about things like power utilization, all that kind of stuff, this all allows us to verify that in real silicon.
Absolutely. So it's kind of representative of how a customer would use it, right? It's it's in an ASIC technology. We can start to look at all the KPIs, power performance, security performance against things like SCA, and then again we can start to look at more advanced threat models, things like fault injection and these type of things. It's easier to do that on a real product as opposed to trying to do it in pre-silicon simulation or using FPGA. Yep. It's more reflective of what a real final product would look like.
But isn't that the wrong way around, right? If we want to have the NIST standards compliant PQC, but we've already baked it into silicon, don't we have a non-compliant silicon chip?
Well, not exactly, because I guess part of what we have within the platform family is the flexibility. It's very much a hardware, software co-design IP. That allows us to update the firmware of the IP to basically modify the algorithms to be standard compliant, or make it more secure from side channel, all these type of things. So the test chip itself is completely programmable. We can download any new test code and use firmware for the algorithms onto it. So this will be standards compliant within weeks.
So therefore that would kind of make it the first PQC standards compliant stuff in silicon then.
We know we have one of the first coprocessors in silicon, and then we'll make it standard compliant. So yeah, you're probably right.
Okay, so that'll be really useful to NIST, because I can't imagine that at any other time in the standardization process there's been implementation in silicon that could be actually tested.
I don't imagine so. I think we can be pretty safe in saying this is the first implementation of Raccoon in silicon, right? Yeah. So it was put forward by PQShield. Our research and engineering teams collaborated on this development, so that's really key. Raccoon itself is quite unique in that it was developed from the ground up to be side channel secure. So it's been developed to be what's called masking friendly, which is a countermeasure against side channel attack. So having that in silicon is really important for testing it. It's the way it's implemented, can be extremely secure, but that makes it hard to test prior to having a piece of silicon. So having that now in our hand means we can really show the strength of Raccoon against side channel attacks.